Yeah.
Alright guys, this didn't work out too well on a screencast, so I'm just going to put it on the board. I'm going to try to talk loud, so hopefully you can hear me. So for problem number 2, we had this circuit. We had resistors A through G, and the first step is to try to find the total equivalent resistance on the circuit. So the first thing we want to do is we want to look for resistors that are either parallel with each other on two different branches with no other resistors in between, or they're in series with each other, which means they're end-to-end with no junctions in between. And so for this particular resistor, I see B and C in parallel with each other, and I see E and F are in parallel with each other. And so I'm going to calculate the equivalent resistance of BC using my resistors in parallel equation. And so 1 over RBC should equal 1 over 8 plus 1 over 8, which is 2 over 8, which is 1 over 4. So RBC is 4 ohms. Then I'm going to do the same thing for EF. So 1 over REF is going to be 1 over 6 plus 1 over 3, which is the same thing as 3 over 6, or 1/2. So REF is 2 ohms. So now I'm going to redraw my whole circuit, and I'm going to replace individual resistors B and C with an equivalent resistor BC, and I'm going to do the same thing for E and F. So we have A, BC, D, EF, and G. And then A is still 2 ohms. BC we just calculated as 4 ohms. D is still 5 ohms. E and EF we just calculated as 2 ohms. And G is still 7 ohms. Alright, so now I just have 5 resistors that are all on one path, so now I just have a simple series circuit. So to get the total resistance of the circuit, we're just going to add all those numbers up. So if I take 2 plus 4 is 6, plus 5 is 11, plus another 2 is 13, plus 7 is 20 ohms. Now to find the total current in the circuit, I'm going to use Ohm's law. So I equals V total over R total. So I had a 120 volt battery divided by my 20 ohm equivalent resistor, and I get a total current of 6 amps. Now, since all of these resistors are in series, they all have to have the same current of 6 amps. So I can go ahead and put this 6 amp value for each individual resistor. And then once I've done that, I can use Ohm's law, V equals IR, to find the voltage drop for each individual resistor. So 6 times 7 is 42 volts. 6 times 2 is 12 volts. 6 times 5 is 30 volts. 4 times 6 is 24 volts. 6 times 2 is 12 volts. And what you will see if you add up 12 plus 24 plus 30 plus 12 plus 42, it adds up to the voltage of the battery of that 120 volts. So that's a good way to check our work. Alright, so now we're finished with resistor A and D and G, but we still have to deal with BC and EF. So when I look at equivalent resistor BC, I see that it came from individual resistors B and C, which were in parallel. And if they're in parallel, they have to have the same voltage, and that voltage has to be 24 volts for each of them. And then I can find the current through each one, because I equals V over R. So 24 volts divided by 8 ohms is 3 amps. 24 volts divided by 8 ohms is 3 amps. And then I can check my work. 3 amps plus 3 amps adds up to my equivalent of 6 amps. Do the same thing for E and F. EF came from E and F in parallel, which means they both have to have 12 volts. And then divide the voltage by the resistance to get the current. So for E, 12 over 6 is 2 amps. For F, 12 over 3 is 4 amps. If I check my work again, 4 amps plus 2 amps is the 6 amps that we see here. So everything's good. So it's best if you organize your answers into a table. So we have our resistance in ohms, our current in amps, and our voltage in volts. And we have resistors A, B, C, D, E, and F and G. And then we're also going to have our totals. So if I go through my circuit, I see that A was 2 ohms, B and C were both 8 ohms, D was 5 ohms, E was 6 ohms, F was 3 ohms, G was 7 ohms, and we got an equivalent resistance, or total resistance, of 20 ohms. Now, if I go back to my diagrams, I see here that resistor A was 6 amps and 12 volts. I see that resistor B was 3 amps and 24 volts. I see that resistor C was 3 amps and 24 volts. I see that resistor D from this diagram over here was 6 amps and 30 volts. I see that resistor E from this diagram up here is 2 amps and 12 volts. F from the same diagram is 4 amps and 12 volts. And then G from my diagram over here is 6 amps and 42 volts. And then I also see right here where I got my total current was 6 amps. And of course my battery was 120 volts. All right, the last thing we're going to do is find the power in watts for each resistor and for the total circuit. And P always equals I times V. So if I do 6 times 12, that should be 72 watts. If I do 3 times 24, that should be 72 watts. 3 times 24, once again, is 72 watts. 6 times 30 is 180 watts. 2 times 12 is 24 watts. 4 times 12 is 48 watts. And 6 times 42 is 252 watts. Should have brought the key with me. Hopefully all those numbers are right. All right, and then 6 times 120 would be 720 watts. And then your last check is to make sure that energy was conserved, because all your individual powers should add up to your total of 720. So if I take 72 plus 72 plus 72 plus 180 plus 24 plus 48 plus 252, I should get 720 watts. All right, guys, good luck on homework problems 3, 4, and 5, and we'll see you in class tomorrow.